Perfect. So, hello everybody. I'm going to talk this afternoon about secure or insecure remote operations, and essentially covering the topic that every admin tool is essentially an attack tool. And the only difference between remote managements for IT or a legitimate user is context. So that's something we all understand. But we're going to discuss this topic in a way and show some really good things for red teamers, as well as the detections. So I'm going to play red and blue all around the topic. So I'm gonna have a lot of things to show, hopefully for both audiences. Before we start, how many red teamers do we have in the room? Yeah, feel free. Okay, not that many, but you're gonna be pleased. How many blue teamers we have in the room? Okay, a bit more, but we're gonna level it up in a way. So a bit about myself. I'm based in Israel, a security researcher as well as a hacker from the 80s. I've been around with computers for a while. I have a red mind, but a blue heart. So essentially, as a red team trainer in different organizations around the globe, at the end of the day, all I do is just help the blue team get better. Co-founder in a company called Tenroot, a niche boutique cybersecurity company working with Fortune 100 big companies, banks, all around the world, as I said. And also known for some of my work on Active Directory. Active Directory is how I call Active Directory, including being part of Javelin Networks, ex-Israeli Air Force and Intelligence Corps that we sold to Symantec in 2018. I had the chance to work for Microsoft in the 90s and early 2000s. I was actually the only guy I knew in my surrounding in Microsoft back then that had the Linux with the Lilo, the bootloader on my laptop, and I was very afraid that people will find out. and also do in my spare time other activities. I love to volunteer for Youth at Risk, as well as play the guitar with my progressive rock band and fly planes. Everything is a bit more calm up there in the sky. I want to start off by saying that ChatGPT was not used at all in making this code and tools and presentation. Not because I didn't want to, because it's just wrong, at least for the things I want to do. It wasn't helpful at all. On the contrary, everything was incorrect, everything I asked it to do. It's probably improving, and with the time we all learn what generative AI can be good for us and what still has room for improvement. But even when you give it feedback, it's still protecting its inner deterministic truth. It's protecting the bugs. And these are logical bugs. Keep in mind that they don't generate errors. It's just that the code is wrong. So it's just keep that in mind. So what we'll talk about? First of all, we'll kick off with talking about the remoting mindset, the way to think about, and we'll give quite a few living off the land examples. Then we're gonna dive a bit more specifically into WinRM, Windows Remote Management, and PowerShell remoting for, like I said, both red team and blue team operations and defenses and evasions, bypass of those defenses. Then we'll dive into how credentials are exposed in the destination during remote operations. And we'll show why you shouldn't trust Microsoft documentation. I'll show you some quick research that's still trying to figure out why it works this way. And I get a TGT with 0 secrets in the machine. And we're gonna also show you how to prevent lateral movement without paying money to any company. Obviously GUI is nice, but we're gonna drop the G and just stay with UI. So most of the examples will be CLI based. So living off the land is a really important concept. Whether you're a blue teamer or red teamer, you have to respect that you don't have to introduce malicious code necessarily if you obviously can blend into the environment. There are lots of ways to do that. And like I said, we look at you should look at every management task and ask yourself if it's a remote management or lateral movement by an adversary. So there are multiple LOL bins in the operating system that can actually generate remote connections to machines that are built in, baked in the operating system. Obviously, RPC, the Microsoft proprietary version of RPC has been around for a couple of decades with WI and distributed COM. Then there is this API heaven around it. All the inter-process communication methods that we'll talk briefly about. I'll touch a bit some nice attacks if you don't know and how to prevent them on RDP, brute force, man in the middle, things like that. And like I said, the topic will dive a bit more deeply is for better and for worse, for blue teams as well as red team, is why to use PowerShell remoting and how we can bypass that as well. So RPC obviously is a system service that needs no introduction. All of you know it and work on it. And it's essentially, if you look at the definition, and it's important to look at definitions sometimes to understand better, it's data exchange and invocation of functionality located in a different process. Why mindset is important? Because we are not running process remotely on a different machine. We are triggering and exchanging data, which should tell you that there is data exfiltration potential here, and invocation, running code on any process that is different than ours. It could be on our same machine, it can be on the same LAN, it could be also in a remote location. And obviously the RPC service serves as not only the endpoint mapper to map the sessions and allocate higher ports, but also as the COM service control manager. And many services depend on RPC. For example, I don't know if you ever enumerated the RPC subsystem process service, but if you increase the buffer and run a num depend, so you will see this is an average Windows 10 machine. So this is roughly 200 something services, almost all your services in this way or the other depend on RPC. And RPC subsystem is all over the place, right? And it also uses a few ports, namely, of course, 135 and all the ephemeral ports, the dynamic port range. But if we speak about ports, you think about, for example, an average domain controller on your on-prem infrastructure. Many ports, as you can see, that are there to exploit. Many different protocols, different ways to play with pre-authentication. There is web services here, and RPC and LDAP, and so much more to play around. So the first thing is a nice trick for you to check what ports or protocols does any tool use. For example, if you want to know what PSExec uses, or whatever tool you have, QUser, QWinSTA. So obviously you could look at that with a pickup, with Wireshark or whatever, but this can be also very nice and a quick and dirty way with just creating a netstat loop. Sometimes when I'm in the field and I don't want to install or begin to do some cumbersome tasks, I just create this very quick netstat loop. All the code in this session is up on my GitHub page, so you'll get it later. But it is a very simple netstat loop that just keeps querying for any changes in a specific remote management potential ports and protocols. Looking at RPC, WinRM, MSTS, etc. So you can see, for example, the minute I opened the MSTSC, the Microsoft Terminal Service Client, immediately there was established connection to port 3389. If I'm running a WMI query, in this window you see that there is a PowerShell firing up in port 135 on process ID 824, right? In my local PID. Of course, keep in mind that also while the task was access denied, because there is authorization failed, but authentication didn't. So, and of course, it's not weird that 825 is my RPC endpoint mapper and the subsystem. But if I run WinRM, in this example, I'm running PowerShell remoting. You can see access was denied, but there is no port shown because it's that fast. So the timeout for the sessions that we're used to see in other legacy protocols, RPC, etc., will not be evident in WinRM. So that's a point to keep in mind. That's because the service is fairly new and also drops the connection immediately if it's not authenticated. If we will run now the same command for PowerShell remoting with WinRM, with a user that does actually have permissions that will not get access denied, and we run basically the same thing, just fire up invoke command. ICM is the alias for invoke command on this remote computer, and just asked to run ipconfig on that remote machine. Now when you look at the loop above, you will see for a brief instant, you will see port 5985 was fired up. Immediately it goes to time wait and immediately it disconnects. So speaking about RPC, I'm sure you know about these errors, RPC not available, which is sometimes not, you might think that the computer is not available. It's not on the network, it's maybe disconnected or shut down. But many times this can be caused by Kerberos clock skew, the time difference between the client and the domain controllers. So just a quick tip about how you can fix this clock skew remotely. You can do that either with WMI, with NTLM, using the IP address, obviously, because you want to trigger negotiate NTLM authentication package and not Kerberos, because Kerberos is broken. Or you can actually do that also with WinRM and just make sure that the Windows Time Service initiates remote sync, resync with the domain controller. So you might see errors like that, extended error, or RPC not available. These might be the errors that you might encounter. And if you try to run RPC not available, right? So if you run this WMI query, you would think maybe this computer is offline or is not connected. But what if you would run it with a more mature remote management option like WinRM, like PowerShell remoting, you will see there is a time difference between the client and the server. Okay, so this error message makes more sense, right? So with that, I know how to solve it. Like I said, there are multiple ways to solve that. One of them is just to use PowerShell's ability to cast local variables to remote sessions. So I'm just gonna put the date of my local machine in a variable, and I'm just gonna cast it over with NTLM to the computer's IP, and just use the $using option to essentially set the date of that remote machine. And that's exactly what it will do. So I'm just gonna invoke this command and set the date. And once we do that, so at least after that I can solve this configuration problem, whatever, but now I can actually access this machine successfully. Speaking about IPC, which is a part of how RPC works, inter-process communication. So in IPC, what's important to remember is that we can exchange pass strings, objects, whatever we want between processes, whether local or remote. And this can be one-way, two-way, encrypted, not encrypted. All these beautiful options you can control, especially when you think about named pipes communication. That can be really, really interesting because we can actually use named pipe, essentially IPC, for a command and control channel, especially in the LAN when you want to do in an engagement to change data or exfiltrate data without socket bind. So keep in mind that you don't need to open any firewall port, and even without local admin privileges, because we don't need to bind to a socket, we just ride 445, we can get the inter-process communication to work for us. So I just want to show you a one-liner PowerShell named pipe that you can actually communicate between processes both locally and remotely. So this is the one-liner. It's very simple. I create an object, a new pipeline, a named pipe client stream, give the pipe a name, my pipe, and while I have information coming from the stream reader, I just execute the data that is coming. So here I have another process on the same machine. I'm just going to connect with a name pipe server stream and just to use the stream writer to write to that pipe. And as you can see, everything I'm running here, I just write it to the pipe and it gets read by the stream reader in the other process and gets executed. And why I'm showing you this? Because this is living off the land, very simple. EDRs won't stop it or won't try to do anything about that, because in your average Windows machines, same as RPC, you have hundreds of name pipes, and nobody wants to, if there is something that an EDR doesn't want to do, is to kill something that might be legitimate, that maybe Excel needs or Office needs or whatever. I can also, of course, use this in the same way, just the same one-liner for remote operations. I just changed the client stream to point at an IP address. And essentially, I have an interactive reverse shell or whatever that is hard to probably detect. Even if you want to, it will be very hard to understand who is malicious and who is not. And as you can see, everything I run here is executed. So let's talk about detection, blue teamers. Yay. So no ETW baked in. There's no really ETW provider. You will need to create and install a file system mini filter driver. And actually one was created, at least one. Probably GitHub has a few more, but you could actually probably use this project, the np-etw. There are other ways that you can observe name pipe events. For example, you can turn on, if you really want to, kernel object handles monitoring, but this will give you information about all handles that are open and closed. This is very noisy, so you'll get a lot of event ID 4546. If you want, you could obviously enable that. You can also use Sysmon, but then again, very noisy. You will still have to filter the pipe event on match on the XML, then you will have to filter that afterwards. My personal favorite so-called detection is to try to really monitor and filter by SMB open files with a prefix of backslash that you really know that somebody opened that and it's not a file. You don't see a PDF or an Excel or whatever. You will see actually a pipe that looks like something programmatic. So you go ahead and try those detections. Let's speak about Windows admin favorite feature. Woohoo! Who doesn't love ransomware deployment protocol? Really great feature. I can't believe, you know, in late 90s in Microsoft, in NT5, to the days it became Windows 2000. I can't believe we never imagined that it will be used in the ways that it's used today. There are many RDP attacks and potential vectors, adversary tools, obviously brute force. The ways to circumvent that is all the classics. Change the default username, especially if it's pointing outwards, God forbid, if you have an RDP server on an external interface to the internet. You can change the default port. That makes a lot of hard times to adversaries that will look for port in Shodan, etc., 3389, and not the default port that you might be changing in the registry. Configure NLA, network level authentication, etc. Another vector is TS shadowing, which is essentially a combination of bad practice of IT admins. I see it all the time in pen testing, admins leaving sessions that are disconnected and the session is there. So if you pop up, if you spawn a system shell and just use tscon, you can reconnect to that session without knowing the credential. This bypasses password length, MFA, everything, because you're reconnecting to a previously authenticated session. That's really bad. So that's a bad practice. And there are a lot of man-in-the-middle tools, right, that you can use. So in RDP man-in-the-middle, you can really be sure that you will get at minimum the net NTLM, essentially the NTLM hash baked in its hashed format with the net NTLM in the network. You can also get clear text password in the network, and without the other party noticing that this attack even happened. But you will need to turn off NLA, network level authentication, which was the default in Server 2003, etc. But you can actually do it even today. It downgrades the session, it fakes the certificate, and it actually attempts CredSSP in order to get that clear text password. And what's the beauty about this is that the victim is totally unaware. So I'm gonna pop up in my box here one of those man in the middle tools. There are a few implementations. You see the victim on the right is connecting to an RDP session. You immediately see that the listener, the man in the middle, has already kicked in. And what you will see on the right, as you can see, there is the behavior is totally normal. So the victim doesn't know even, except that the connection takes a bit longer than he normally would expect, maybe 10 seconds, a bit longer. But on the left, you can see we got the NetNTLM just now. So I got the NetNTLM, successfully downgrading the session, tempered with the NTLM response. And now, that's the beauty. We show the victim, of course, the self-signed certificate. Because RDP, of course, by default, in your network, you will always, maybe not always, but most common is that you will use the default self-signed certificate. Once we connect with that, this was a fake certificate, right? It's not the real one. And as you can see, the victim connected to the session, everything is fine. He's not aware that everything he's typing, including the clear text password, was forwarded to us. So this is classic man in the middle. How can we get the clear text password from any RDP server? Well, I would say the best thing is probably to just simply flip the registry key, or just use this built-in function of setting the user authentication required to 0 to disable NLA remotely. This is much more silent and quicker than, you know, ProcDump or Mimikatz or whatever, and we'll get the clear text directly. You can actually use all kinds of spoofing tools, common tools, Invade, Responder, etc., to just relay this registry command. So if you're in the blue team, you might want to just monitor for this change in NLA. Some mitigations detections, obviously you can and should enable NLA. You can do that remotely, centrally managed with the group policy, require authentication using NLA. This will block, if you have NLA, it will block the RDP connection from non-authenticated hosts, meaning a laptop of a pen tester, but it will not prevent the NTLM plus clear text. It will just block the RDP and alert. I will still get your clear text and the NetNTLM, just that the RDP session will be blocked, and you get in the event viewer that this attempt was created. So how can we do it better? So really the only nice mitigation is to just configure server authentication for client in simple ways. We need to configure certificates, what you probably don't do today to any RDP connection, but you should, because this will disallow the connection if a certificate cannot be validated. This requires, of course, enterprise CA, etc., and to generate those server authentication certificates. Keep in mind that even this will not prevent the attacker from getting the NetNTLM, which he can then take an offline crack with the hashcat, etc., but it will prevent the clear text and block the connection. So that's not bad. And of course, you have the classics, MFA, etc. So this begs the question, this very short, basic examples, to admin or not to admin. Of course, what can we use? RDP is not good, RPC is not good, NAPIPE everywhere. So I think we're missing here on something. Because you can perform all these remote management tasks, you know, access SMB file shares, run local processes, do remote event log service management, etc. But we can do all this with PS remoting, PowerShell remoting, utilizing WinRM, Windows Remote Management, which is a service that has been around since Vista, Windows Vista, if you remember, in 2006. PowerShell remoting, always encrypts everything with your TGS, with your session key, single port, does all of this and much, much, much more. So in PowerShell remoting, we're actually working through a web services management protocol, right? We have the WinRM service listening on port 5985 or with SSL in workgroups, etc., 5986. It's enabled by default on all Windows servers from 2012 onwards. You have to enable it on all other operating system versions, all clients as well, Windows 10, etc. It's not enabled by default. It also has a nice additional feature called PowerShell Web Access. PowerShell Web Access essentially helps you to connect from any browser that supports cookies and JavaScript, essentially any browser from Safari, Mozilla, whatever, Linux, Mac, etc. You get a shell inside the browser and you don't even need the client binaries to run PowerShell commands. PowerShell is quite useful, especially when you combine it with the power of jobs. Jobs are essentially run spaces in the background that run PowerShell code with leaving you the session open to just query the status of those jobs. For example, I'm taking now all the active computers in my lab here, and I just want to, first of all, I'll just clean the jobs that I currently have. We have 4 machines here I can see that I got from Active Directory, and I'm just gonna invoke command, run remote PowerShell. All I want to do is just get ipconfig/all from all those machines. And PowerShell remoting, of course, runs the command locally on the remote machine. I just added the parameter minus as job. And what this created is essentially now when I want to look at the child jobs, I see that the remote job was run on all those machines locally. I can see the status, the state of each machine, if it's completed, failed, still running, and I can receive the job output. So as you can see, now of course I can just also pipe it to a file. That's really nice because you know, in a matter of seconds I got the ipconfig/all of all those machines without going anywhere. You can also copy to from remote sessions. There is a to/session from session between VMs, between PowerShell sessions. You can also cast local variables and local functions to remote sessions. For example, in this case, I don't have SMB open. I just closed port 445 to that remote machine, LonDC1. And I don't have access to the SMB shares, right? You can see here also, just to make sure, with a quick timeout, that I don't have access to port 445 to CIFS SMB. But still I can create, I have PowerShell remoting open, port 5985. I created a new PowerShell session, and now I'm going to invoke to that session. I'll just look at the local ctemp directory of that machine, just to make sure that I don't have any files named text, whatever. I'm just going to create locally on my machine a new text file, right here, whatever I want, just save it. And now I can, this is the content of my local file, and I want to copy this file, but I don't have SMB. But I can use the PowerShell copy to session or from session. I can copy to that remote session this local machine from my local file, and the destination should be at the remote machine. So the ctemp of that remote machine. Now when I invoke command, of course, you can see the file was properly copied, and I can also see the content. So for Blue Team, just enough access is really nice because it really creates a secure, constrained, delegated remote access endpoint. It utilizes PowerShell session configurations, which is, if you don't know about this, you should really get more into it, because this really makes adversary life harder, much harder. It can give you a lot of logging and visibility, transcriptions, constrained language. We'll talk about virtual accounts in a second, but mainly it can allow you to create role-based access control. You can create a shell essentially per role for the DNS administrator, for the supplier, the vendor that comes just to fix something in your specific application. We can give them access to domain controllers just for specific commands down to the value of the parameter. To this very specific level, you can whitelist things very deeply with that. Just to show you a very, very quick example of PowerShell session configurations. For example, here I'm connecting remotely to a machine called LonCL1. As you can see, I can run shutdown, ipconfig, whatever, because by default, PowerShell remoting will give me a lot of commands, right? I'll just do a quick count. You can see I have almost 3,000 PowerShell commands available in the default remote session. But what if I connect and I connect again to a PowerShell session to that same machine, but now I connect to a configuration that I pre-configured called SecureCon, and I'm using a specific credential just for a user that I delegated that can run this specific configuration. And now when I connect with this user, again, essentially it's the same session, but no, not at all, because now if I tap normally the command, it will not work. None of those commands is available for me. So what's happening here? It's the same machine, exactly the same machine, same protocol. There you go. I just whitelisted very, very specific commands for this session. And this really makes role-based delegated commands. You can see start service, I only give them audio and spooler or whatever. None other service will work. You cannot stop or start any other service. That's really powerful. And that begs the question, okay, so now when we work more with PowerShell remoting, because it's very cool for IT and for Blue Team, so how can we map or hunt for those sessions? So that's a good question, because by default, Microsoft does not have tools like that available. You can probably use EDR, Sysmon, etc., and just look for WSM prov host exe. You know, this is the process that gets created in the destination when you connect with PowerShell remoting. You can obviously look at the relevant ETW providers, WinRM and PowerShell operational logs. By the way, WinRM has event ID 6 for the client operation when you connect to it, and event ID 91 on the destination, logged to the operational log. But you could also try one of my scripts. I will not run it now for the sakes of the time, but on my GitHub there is a script that enumerates the web services management URI and the WSMan instance, and you can remotely query all around your networks, remote PowerShell sessions, and see who connects from there and from where and how long it has been idle also. So this can be really useful when you're doing threat hunting, especially in live incidents. Let's speak about remote operations. So I like to poke around Microsoft documentation because, like many of my fellow friends, speakers, and researchers, I know that many times the documentation of Microsoft is not accurate, to say the least. So I poked around one of their recent papers from recent months, updated a few months ago, about credential exposure in administrative tools and logon types. So, by the way, you should look at it because some things might interest you. For example, remote registry service that we all read and we don't want to use it. It's so not secure, but actually to query a registry setting using remote registry service is more secure than to do it with PSExec, for example, in terms of credentials exposed on the other side. So let's get the advice from Microsoft. Let's look here, and you see Microsoft mapped all those different connection methods, as well as if there are usable credentials on destination or not. And for example, because we spoke about PowerShell WinRM, let's look here at the document, and as you can see, there are no reusable credentials on destination, right? Because it's logon type 3, network logon. This makes me think, because I know in the host level, maybe we can duplicate the token, and even if we don't have any ELSA secrets, no NTLM, no TGT whatsoever, we can still get a full token from that primary token. So let's see if that works. So now I'm connected to this machine, LonCL1. If I will show you the unique usernames of all the processes in the machine, as you can see, I have no process for administrator, right? I'm running as this user, Adam, and I connected to a different machine, LON DC1, and from this remote machine, I'm connecting with PowerShell remoting, okay? So now I'm actually connected in a live session, continuous session, from that remote machine. And I'll go back to LON CL1, and now as you can see, because I connected remotely, I have a process by the user administrator, the domain admin of this domain. So let's run Mimikatz, okay? Let's run Mimikatz on this box now that the session is open and I have this process running in the background, and dump the credentials, all the credentials we can find, classic secure LSA logon passwords, dump it to this log file, and let's see, no credential guard or whatever, doesn't matter anyway. And as you can see, there are no credentials for administrator because Microsoft is right. There are no credentials exposed. I'll also show it here for you. Select string, show the unique username. Yeah, no administrator, okay. No NTLM, no nothing. But we do have a process. We do have a process, WSM prov host, WSM prov host exe. And this process, if we run something like token manipulation, full token duplication, this one is a classic PowerShell, quite veteran from PowerShell Mafia, the PowerShell framework, offensive framework. Now, as you can see, we duplicated the token. So we have a primary token, delegation token, not impersonation. And when we access domain controller to the C drive, we get access. Why is this possible? Okay, so the documentation is maybe right on paper, but in reality, I have domain admin. So what can we do to mitigate? I promise you, blue teamers, I'm not leaving you stranded in the field. There is a mitigation. Ta-da! Virtual accounts. Microsoft is a very responsible company, and that's why it created virtual accounts. If we look at the role capabilities file of PowerShell session configurations, we can see one of the capabilities options that we can configure is essentially run as virtual account equals $true. And what this does, this is really a great magic, because once you enable this option, I will show you in a second what happens. Now when I connect to this PowerShell remote session, and I will connect to the same machine, but this time using a secure configuration that actually enforces the process to run as a virtual account. What this means technically is that I get the shell, I get the remote access with all the commands available, and they will execute successfully, but they will run as an account with not with the seed of the account that I'm actually running. So you can see now, if I expand the username, it's not running as Adam or administrator, it's running as WinRM, virtual account, whatever. Also, the seed of the account it doesn't match your domain or local users, and it's essentially something you can do nothing with. This time I'll spawn the new process with a different method, with kernel cactus, a research by one of my colleagues, team members in Tenroot, but it's really the same. I could use the same PowerShell again, but just to show you that the process duplication works, even from kernel, doesn't matter. But now I'm running as virtual account. And if I'm running as virtual account, the seed doesn't match the token that I have, the process token doesn't have the seed that match the domain. So if I try to run anything beyond this box I'm trying to access, it will fail. As you can see also the K-list, when I run the tickets, you can see the tickets I got are locally from the machine. So I'm not coming out to the network as the user I hoped I will be. But as adversaries, if we already got to this box and we have local admin machine, local admin privileges, rights, we can just edit in Notepad this role capabilities file, okay? Because it's a file. So essentially you go to the file and you change it from $true to $false, and that's it. No mitigation whatsoever. Knack, 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 knack. But wait, there is more. Cat and mouse, right? As my friend Fabian mentioned. But we defenders, blue teamers, we can monitor all file configs. We can match by hash changes. We can actually sign the config file, right? And will you really monitor this? I'm just thinking out loud. Will you monitor, sign all config files, monitor for hash changes? As you can see, you take the red pill and you go down the rabbit hole. It's never ending. Static measures are really a pain. It's really about the creativity of the sites. Whether you're a red teamer or blue teamer, this never ends. You also have all PowerShell defenses in the world for you. But sadly, a few years back, we published a research back with my friends in Javelin Networks, Omer Yair and the team, called InvisiShell. It's still working until today. Many EDRs obviously detect it, or the IOCs, but many sometimes don't. And if you just bypass AMSI, then this will work. InvisiShell essentially is working with CLR profiling, what we do there, and it doesn't even need administrative privileges. You will get a PowerShell process without any defenses. It just totally bypasses all the JIT code addresses from all the hooks to the ETW and to AMSI, etc. So feel free to use that. It's quite good for red teamers. Finally, I want to ask you a very simple question. It's so simple that it's amazing how many bad answers you get from ChatGPT when you ask it. How do I prevent domain admins from logging to endpoints? Fairly simple question, right? I mean, it's a question we all ask for ourselves the last 10, 20 years at least, right? A very simple question. So before you ask, you say, yeah, will you buy third-party jump servers, whatever. We just want to stop lateral movement, right? So how can you stop lateral movement? You can think about expensive solutions, and let's say you really want to prevent that, but you want to do it very simple, and you know how Active Directory works. So I want to show you something very basic, but this is more hard for adversaries and red teamers to circumvent than expensive third-party products from experience. Because like I call it, small step for IT, giant step for the blue teams against lateral movement. Let's say you're in a network, no EDR, no segmentation, flat network, no VLANs, no MFA, no nothing. Many misconfigurations, vulnerable certificate templates, whatever, but we just want to set logon restrictions for the user workstations, the logon workstations attribute. It's that simple. So hiding in the properties of an AD user where you visited so many times, there is this logon workstations that instead of giving it the default all computers, you will add specific computers it can log on to. Obviously, in a real world scenario, you will need at least two computers, the one to access and the one to run from, essentially the jump server or the privileged access workstation. Now I'm going to do pass the hash. And believe me, this is the right password hash. Essentially now I have an impersonation token with an administrative user, a domain admin. But now, as you can see, although I'm trying to run, I'm doing pass the hash because my primary token will never work because I'm restricted. I try to do a dir for that domain controller and it says does not exist. Okay, no Kerberos tickets created. Fine. I'm trying to run a WMI command and it says access denied. That's interesting because the ports are open, RPC is enabled and open, and my password hash is for sure correct. Why it's access denied? Something is bad here. Now when I will try to run PowerShell remoting, it also said failed. User or password is incorrect. Now I'm beginning to question the NTLM hash that I got, right? Because I'm thinking maybe there's a problem with NTLM, but no. When I use psexec, it tells me the user isn't allowed to sign in to this computer. This is interesting. right? Because not to this computer, I am on one computer, I'm trying to sign. When I try schedule task, remote schedule task, access is denied. Nothing, guys, nothing works. Even queries, LDAP query. I'm not talking about code execution. LDAP query fails because the LDAP server rejects the client credentials. And this is all one attribute in Active Directory. That's all you have to set. Even if I do network protocols, etc. And trust me, this goes on and on and on and on and on. Now working with system directory protocols, I just create an LDAP connection with this very simple enumeration of member of. I just want to see I just initiate a new LDAP connection, and I try to see the member of property of this user, and the supplied credential is invalid. All this because of this logon workstations attribute in Active Directory. And if you're not sure, maybe there is some other magic in this demo. Of course, obviously, when we do have the clear text password, this will also fail, because you will see even when I type the right password for this user, Adam, that we just restricted, regardless of the pass, the hash, you will see we get this very clear message that there is a problem logging you in, there is some restriction, there is some problem, right? If we go back to Active Directory, just to show you that I don't need even to log off from that session, from the same session, I will just reset it back to all computers, or just I could add just my machine, this local machine. I apply the attribute, no GP update, no nothing. It's directly connected. I run the query, boom, LDAP query works. I get the group membership. Everything I will run now will just work fine. I will try to do schedule tasks successfully, PS exec successfully. Okay, so it was just this attribute. Because we're running out of time, just quickly show you, I have some other scripts on my GitHub page that really reflect you the timeline generation for your SOC, for the analyst to see exactly what's happening while you work with logon restriction. And I also include some scripts to monitor this with some best practices, how to monitor changes for this attribute. So feel free to visit my GitHub page and take it from there. Okay, so key takeaways. Please embrace living off the land as a mindset, as a mentality. It doesn't matter if you're a red teamer, a pen tester, or a blue teamer. Note that credentials exposed on endpoints are not necessarily like the documentation says. And like mentioned earlier with the Dirk Jan, we're gonna understand exactly why this primary process token works on a network level. Sometimes a single configuration goes way further than expensive third-party products. And PowerShell remoting rocks. It's really the best way to manage the environment, but keep in mind that this really is something you need to log and continuously monitor because it can also be bypassed. And remember, at the end of the day, all of those is just tools. It's not bad nor good. That part is really up to you. And at the end, everything is a set of nested if statements, including ChatGPT. It's just a lot of if statements, right? That's all it is. Dziękuję bardzo.